Okay, Rhoda, so we can go.
Good. Okay. The sets, the 4 stations, and I must just do something different. I'm going to remove the column selection. So I'm continuing with the data that we had yesterday to share between us, and I'm going to demonstrate, and you might want to make a few notes, but I'm going to suggest that once we do it, you're used to using the dialogues, so we don't need to work in parallel. Instead, you apply the same ideas to your own data. This is where it gets for real. You remember the good news from Ghana yesterday, and I have to say that it was very impressive, the extent to which you can supply data, and those data are easy to tidy. We can discuss later whether you could make it even easier, but it's really impressive the way the data come out of the database, and we can then move quickly to analyses. And once, of course, the checking is done, if there are mistakes we find in the data, then they ought to be corrected, not in R-Instat, but in your database, so that then the data that come through, we can go straight in rather than doing the inventory and checking. We go straight to preparing the data for analyses with start of the range, end of the range, all sorts of things, which we're going to look at tomorrow. But before then, I want to see, are you just as impressive on the quality of your data? And I've had 2 stations which are in the library, and they were impressive. So I'm going to show you what we found a little, which is a bug really. And whenever the program is never going to be perfect, and so I want to show you a bug and how you get around it, and you will find more of these. But gradually, there aren't so many in the analyses we're doing because we've practiced this quite a lot. So I'm going to box plots, which we like, and then I'm going to QC temperatures particularly. So let's have a look at, oh no, before that, I'm going to try something which is an experiment and is quite recent. You'll notice that we have 45 columns here because you supplied us with a lot of elements. But today, I'm just looking at the rainfall and Tmax and Tmin. So to simplify the data, you don't need to do this, but I just thought you might like to look at it. And meanwhile, it's a test. You know how we filter rows, which means you have a subset of the rows, and then this goes red. Well, you have so many elements. I would like for now to just select the columns. And I'm going to define a new selection. I'm going to have the station and all these columns down to the day of year. And then I'm going to just have the rainfall and the minimum temperatures and the maximum temperatures, just so I can concentrate on those. And I'm going to add that condition, and I'm going to return, and I'm going to say, okay. And now you notice that we only have 9 columns out of the 45. And that's just made my life a little simpler if it works. And you'll notice now it is the columns that are in red to signify that we have not all the columns, but just some columns we've selected. So I've defined my data as climatic. We did that yesterday. And so now I'm going to go with my restricted columns to check data and box plots. And I'll reset this. Now, I'm quite comfortable that I have here the data, and I'm going to start with the maximum temperatures, Tx. And I'm going to have a look at a box plot. I'm going to look at the seasonality, so I'll leave that, but I would like a separate box plot for each station. So I'm going to change that to facet wrap. So the main thing I've done is put in the element that I want, and then I've got the facet wrap, and then I've got that. I'll have a look. Let's see what we get. And here we are. You have a lot of data because they focus attention on any odd things in the data. And here, these data seem very good. I noticed one or two that are slight oddities in the data, and we'll look more carefully at that later. But by and large, you can see the seasonality of your data. Here's Axim, which I think is right down in the south, but on the coast, if I'm correct. And there is the maximum temperatures are down to about 25 in April, May, June, July, August. August is the coldest month here for the maximum temperatures, and April is the warmest month here, but it's fairly constant in the winter months here. And you see a similar thing in your 4 stations. Tamale is a bit hotter, and also the spread of the data is a bit greater, it seems. So the temperatures are more variable from within a month, as they are. You can see here it's quite concentrated. The temperatures are rather constant. And here they're a bit more spread out in Tamale. We'll understand that a bit more later. There's something curious in some of your data. So I quite like box plots. And one of the nice things about them is there's a lot of data here. There's about 100,000 observations, but a lot of them are hidden in the boxes. And so you see the message and the pattern quite clearly. Remember, in statistical analysis, we're looking for patterns. Now, let me change from maximum temperatures to minimum temperatures. And I'll just say, okay. So I've just changed Tx to Tn. I've left everything, and I'll say, okay. The minimum temperatures don't look so exciting because of these values here. There are some very curious values in Accra. And these are, you know, people, it's questionable when is an outlier, but these are clearly very odd. One value in February and quite a lot of values in March in Accra, and that's totally messed up our picture. We can't see what's going on. And I noticed that there are also 1 or 2 odd values that are very low, close to 0. I actually want to worry about those because those look like mistakes as well. Even though they're minimum temperatures, they're very low compared to a lot of the other values. So there's something curious about this value and this value, definitely something odd about these. And then there's an odd value there. So apart from that, the minimum temperatures, I think, never really get to 40. They get into 35, but that's quite high. So 40 is the maximum. And some of them, 0 is rather odd here, and really rather curious. And so most of the time, they're between 15 and 40. And those, clearly, we need to do something about. So, and I can also show you a small problem. I'm going to go back to my graph. Now, the idea of the graphs in R-Instat, and this is very general for all the graphs, and the graphs are wonderful in R-Instat because of a thing called ggplot, the grammar of graphics. And so we're very proud of the graphs. This isn't R-Instat, this is R, that a wonderful person wrote the graphic system that we use. But it's very comprehensive. We try to make it simple with these dialogues, but when you need something different, then you use a sub-dialogue. And so now I'm going to press these plot options because I want to do something about this axis. I don't want it going up to 80 because I can't see what's going on. And so I'm going to press the plot options here. And I'm going to look at the y-axis because it's too big. And I'm going to make a custom y-axis. And I'm going to say the lower limit is 15 and the upper limit is 40, because the others outside that I'm going to have to do something about. And now I want to show you a problem with R-Instat and also how you can solve it. So this is what I call a bug. So I now press OK. And you notice it's done it, but it hasn't done it quite right. And so this is something we must fix. What's wrong? Well, I only have one graph. I don't have the 4 graphs. So all the stations are now together here. And I look back at my dialogue and I say the stations they're there. If I'd got none, then that's what I should get. But I had facet wrap. So I'll make facet wrap again. I'll refresh it. And then I'll say, OK. And now my graph is fine. So I want you to notice that this is a small problem in R-Instat, that when you use the sub-dialogue, at least in that way, it forgets that it's supposed to have 4 graphs and gives you 1 graph, and you have to remind it. So that's what we would call a workaround. We can solve that. It's not a serious problem for you. And I now want to have a look at the minimum temperatures. And remember, there's some nasty observations somewhere, but also now I can see the minimum temperatures more clearly. There isn't so much seasonality in your minimum temperatures. They're roughly constant. There was much more seasonality in the maximum temperatures, but the minimum temperature, and then I can now see that there are some more values, unlike the maximum temperatures, which are looking slightly odd, which I hope I can isolate because they're not so extreme, but a value in January at Kumasi of nearly 35 degrees is quite high. When you think that the next highest was about 27. So it was really quite a jump. I wonder if it would have been 25 rather than 35. Was that a typing error? And here we have 2 higher ones as well. Again, odd to have just those 2 days, and we want to look at them. We're not yet ready to correct. We've got the proper quality control to come, but you can see we've got some work to do. And remember, we've got the 70s and the 0s, which I've omitted here because I've got the axes. So I like box plots. They direct me forward, and I can now see that I've got some work to do, and I've got more work to check the minimum temperatures, Tn, than I have the maximum temperatures. So I do have some work there to do. And you might wonder whether the very big values and the very little values, how did they escape your quality control? Because some of them were very big, and we'll look at them in more detail later. But you begin to see that using this new tool is going to help your data be of even better quality than before. So I'm going to now do this for rainfall, And then I'm going to go on to the quality control dialogue and then turn it over to you to try doing the same things. And whether you do the box plots and the quality control or just one of them is very much up to you. And so now the last thing I want to do here is go back to the dialogue. And most people would not look at rainfall because box plots are not meant for skew data. And so I'm going to just do the box plots for the rainy days, and I'm going to make them variable width. And I'm also, you could have done this for the temperatures usefully. I'm going to change this to 2.5. Oh, I don't like these things. 2.5. So I'm going to have a little look at rainfall and see what's going on. Aha, and I've got a problem with the rainfall. I'll show you my problem with the rainfall. And you can perhaps see what the problem is. That is a problem. Now, the problem is that I've left my axes as they were before. And so the rainfall is only between those values. I don't want that. So I now want to go back here and I want to take my plot options, and I don't want to have 15 to 40 and just plot only the values between 15 and 40. I want to return. And now I know that I'm going to mess up the station. So I'm going to do facet wrap again. And I'm going to say, okay. Now I've got better box plots for rainfall. And I'll have another look at them here. Kumasi has quite a lot of rain. It sometimes has, it's had 800 millimeters. That's quite a lot. And it's got two values that are about 700 millimeters. So again, these are very, very heavy rainfalls. I can believe rainfall of 250, 300, but 700 millimeters in a day is really quite a lot. So I think I've got to do something here, and I could change the axes and look more carefully. The other thing you notice is Tamale up in the north, the width of the box is proportional to the number of rainy days. And so you can see here very clearly that Tamale has almost no rain in January and November and December up in the north. The other places have less rainfall, but they do have the places in the south. Kumasi is a little bit further north, and again, the January is there and December is there. So this extreme seasonality, and I suppose also it's interesting. Accra, no, maybe all of them. No, Tamale here, Axim seems to have quite a lot of, has a chance of rain all the way through. Although I have to say the heavier rainfalls are in the rainy months. And there is an element of bimodality, as you would expect. So the one range is there, and then round August there's less, and then October is also quite rainy. So so you have the bimodality in your coastal places. So that's the box plot, to explore your data, but it's not letting you focus in on possible mistakes. So I hope you like the box plots. They're rather fun, especially once you've corrected your data. I find they're a nice presentation of the actual data. Let's be clear, we're still on check data and we've got the box plots. So the second dialogue I want you to look at is the quality control for temperatures. And I would like to go through, I'd like you to understand the system for that as well. Now, we've called this element 1 and then T max in brackets because we built it initially for T max and T min, but you can use it for any element. So it would work for sunshine hours and humidity and various other things as well. And I'm not going to bother, you should bother with the acceptable range, but those are obvious and those are probably done. And so you should consider what you want for acceptable range, what's acceptable for T max, that's element 1, and what's acceptable for T min. You might want to change those limits, and I'm not going to bother with that, but you could do that when you start. That's a useful starting point. So this is the acceptable range for T min, or the second one. And you can run this with just one element. You don't have to have both. You can run this with just one. And then the only thing you can't do is this difference thing, because that's the difference between T max and T min. So I want to show you the first one here. So this is days. And this is an example where it's easier to explain it once you do it. This is from Climdex with the indices, but this is the quality control. And they say, if 4, they have the limit 4, but you've got too many days with 4s and 5s, so I'm going to have 6s, and there's still quite a lot with 6s, as you'll see. In fact, I might even have 7. The 7 is really already quite extreme. So let's have a look. What does this mean? So, and what's the system in R-Instat? Okay. So the system is we produce another data frame, which is QC temp, with all the days here. 385 days are accepted here. So let me show you what that means. And you've got the true and the false, and you'll have to practice and play with this. But let me start at the very top. The very top is E2, which is minimum temperatures. And it's saying that the minimum temperatures for 8 consecutive days were exactly the same. Remember, WMO and Climdex say if 4 or more are the same, then you should worry. Because possibly it means that your observer wasn't really there and just put down the same number. So look, TN was 23.3 for 8 consecutive days. Gosh, that's quite a lot of days over a week. No change in the minimum temperatures. That's really rather odd. And then there was here, this is all in Axim. In Axim, January the 1st to the 9th. Interesting, it's January the 1st, that's New Year's Day. Did the guy really come there? Because from January the 1st in 1970, he put 30 degrees. And on the 2nd, and on the 3rd, and on the 4th, and on the 5th, and on the 6th, and on the 7th, and on the 8th, and on the 9th. For 9 consecutive days, at the very beginning of January, New Year's Day, it was always the same temperature. I'm asking you, did he take a week of holiday and hoped you wouldn't notice and then just put the same number down? Or is that a real recording? So you should worry about that. And then it's not clear to me, because I'm not a meteorologist, what you should do about it. Do you make those now missing because he wasn't there? Or do you do something? Well, I wonder what you should do. And to me, it is very suspicious. It all starts on the 1st of January. So that's quite interesting, isn't it? Yeah. Did you ever think of looking carefully at that? Here are 7 days for maximum temperatures, 31.7. It's an interesting number to have. 1970, the 12th there. I wonder what the biggest number is. Here's 10 days at 30.6, 10 consecutive days, right from the 17th of February in 1974 to the 26th. I wonder if they're the same for all the stations. Let me just have a quick look. I'm going to look at levels labels. And there were 127 days that are flagged as being suspicious for AXIM. And the observers at Tamale get the prize because you don't want to be here. Kumasi had 110, Accra had 124, only 24 at Tamale. It's good to have small numbers here because these are the numbers of suspicious days when maybe they weren't there. And remember that WMO says use 4 here, whereas I've used 7. 10 days, exactly the same. Let's go down a bit further. Can we beat 10? Oh, there's 11. And exactly 30 degrees. What a coincidence. But what's not so obvious, you guys in GMET, what are you going to do about it? I have some ideas, but I wonder what you're going to do. Because if these aren't real recordings, do you put these down at missing? And how low do you go? Because you're going to lose a lot of observations. And here's 2 lots of 7s, sort of one after another, exactly the same, 31.1. There's an 8. Oh, there's a 12. 12 days. We're nearly 2 weeks at 22.8. Isn't that interesting? Have you ever thought of wondering about that? 11 consecutive days. Do anything beat 12? 12's quite big. No, I think 12 is our record. There's another 10 on minimum temperatures here, 21.1. People seem to like 21.1, don't they? So there's one of the checks recommended to be looking at the quality of your data. So you're seeing quality control perhaps as you never saw it before. Let's have another look at a bit more of your data. And I'm now going to go back to the dialogue. Where's it gone? Back to my check of temperatures. I'm taking that check off and I'm going to look for a jump. So you can decide what you want as the threshold. Our default is 10. I find 10 gives you too many. This is a jump of more than 12 degrees between one day and the next. Let's have a look. Now I go to, you see it's produced another data frame. This was the original one we had before. And this is now the jumps. And there are just 21 jumps. Let's have a look at a jump. And now we notice most of them are in Kumasi. And then there's Tamale. AXIM doesn't have any at all. So there's 21 occasions. This isn't 21 jumps because they come in pairs usually. So let's have a look. Let's take Kumasi here. And this went from 19.3 on December the 17th to 36.2 on December the 18th for the minimum temperature. And notice 36.2 is 6 degrees higher than the maximum temperature. So that's quite big. And interesting that that's in your database, although there is supposed to be quality control. So you've got a value six degrees more than the maximum temperature, and it's quite a lot more than the surrounding days. Let's try another one. And here we have 32.4 on December. This is now 2020 in Kumasi, and quite a lot in 2021. So something's been happening recently. So 32.4 on one day dropped to 20 on the next. And notice the 32.4 is more than the maximum temperature here, and then dropped to 20 exactly 20. Interesting. And so on. Here's another one. 22.2 up to 34.2 down to 22.2. And 34.2 is very similar to the maximum temperature. I wonder what's happening here. And this is now September the 23rd, 2021, was 22.4 degrees. What a coincidence, we've lost the 20. This is 2.4, and then up to 22.1. And then we've got 22.8 and dropping to 4.7 on the minimum temperatures. I wonder which one is wrong. And these are exactly the same. And so on. So, as I say, these are interesting. And then if you're going to continue your analysis in R-Instat, you may want to make some corrections. And I want to show you how you could do that next time. But now I want you to just detect what's going on. So the last thing I want to show you here is in the checking of the data. I'm going back. I'm still using the QC temperatures. And I'm going to look at the difference between Tmax and Tmin. Now, even if Tmax was only 1 degree more than Tmin, that might be suspicious. But here I'm taking 0.0. And I want to see what happens here. And I go to, you notice that we haven't got rid of this first one. That was the first check. Then there's the second, and now there's the third. And let's have a look at this. So this is when Tn is either the same or more than Tx. So here they're both 25 degrees. The difference is 0. And they are, and I noticed that these are 2017 seems quite interesting. In 2017, in February, we're getting quite a lot of very interesting values for Tn. And that's going right through Feb. So February 2017 in Axim is looking rather suspicious for either Tn or Tx. It looks like it's Tn, which is the same as Tx. So that's interesting, isn't it?
Sure.
And that goes right through February. So, and that I find is quite common, that accidentally Tn has been put there instead of Tx. So there's often a nice correction you can make. And here's another interesting series. This is now 1951 in Accra. Can anybody guess what's going on here? This is Tn, 74 degrees. 75, 82, 74, 70. I'm not quite so clear how to correct these easily. Can anybody think what's happened here? I have a theory.
Does anybody know? But just ask the question. Yeah. Which year is that? 1951.
1951.
And so, Madam Elikem is suggesting that they probably are still in Fahrenheit.
I think that's absolutely right. I think they were in Fahrenheit and should be transformed into centigrade. So, yeah.
Okay.
So
that's the work they need to do there. From 1951. Axim. No,
and
can't even Accra. Yeah. That's something. 51.
And I notice it's up to the 23rd of March. And the other clue is that it's all these consecutive days in 1951. These are consecutive days. And so I think think that's probably what's happened. So here's a more confusing one, that the minimum temperature was 22.8, and here the maximum was 21.1. Now I'm not quite so clear which is wrong. Is it the maximum that's too small or the minimum that's too large here? So we sometimes have to do a bit more detective work, and I'm quite keen to come back to that when we reconvene. But I think you've now got quite a lot there to be looking at and checking. And I'm going to stop now and assume that you could follow and get some box plots and do some checks of the temperature data yourselves, and add some of your results to the for your own stations, and add a few of the results to the PowerPoint. And then I want to come back and show you later how we could put on them and maybe correct them in a good way. So I want to check that with you. So that's your exercise now. But what I hope you'll find exciting is, of course, you're not just repeating what I'm doing, you're doing these for your new stations. And by the way, I was very pleased that the agromet stations, which I haven't looked at, have imported very easily. So anybody who wants to use the agromet stations, be our guest. You see, these have got rainfall, T-min and T-max, and one or two other things as well. So they've got fewer elements, but very interesting ones. And one group could be looking at agromet stations if they wish. Are there any questions, comments, discussions before I sign out? I then have a special task I would like to report to all of you, but then do it possibly with just Al-Haji or with maybe the team from Gambia, but I think just Al-Haji. But first, can I consider any questions on what I've been showing you so far, or any comments you would like to make?
Yeah. So I think there's one question. I'll say a comment. We wanted to know why we had filtering for rows and we rather have column selection for the columns and not like a filter, I guess. But
so the filtering for rows is both of them complement each other. They're when you've got a large data set and you want to temporarily or permanently look at a subset. And you might want to look at a subset of the columns, and you might want to look at a subset of the rows. I'll give you one example for the rows. I find quite often I want to do an analysis of all 4 stations, and then I would like to print out a bigger graph just of one station. So I want to really concentrate on one station, Axim, let's say, and just have a graph of that. So I filter to Axim. I've got my graph set up for the 4 of them. I then filter to just those rows and give the results for Axim. And then I decide I'd like to do the same for the others, but not have them cluttered with 4 graphs at the same time. Do them separately. So I might want to do separate reports. But I want to keep going from one station to another. So I would like to quickly set up a filter so that I can quickly move from one station to another and do successive analyses. For the columns, the selection is that sometimes you can see here we've got 45 columns, which can be a bit confusing. But for some of the surveys that we have to analyze, we have many hundreds or even thousands of columns, and it's quite hard to then find the ones you want for analyses. So sometimes, again, we want to select a subset of the columns that we're going to look at particularly now. In each case, once we've made the selection, we have a choice. is it a temporary selection, in which case it's a filter or a select, or do we want to make a new data set that and concentrate on it, in which we make the selection or the filter or both into a new data frame, which has just what we want to. I hope that helps if I've heard the question.
Yeah, I think it's okay. The basic thing is the flexibility that is going to provide. Yeah, unlike the rule which is just straight away.
The column is also straight away.
No, but the column, like you said, no, that would have put.
By the way, the filters of rows we've had for a long time. The filtering, the selection of columns is quite recent, and we still have a little to add to that. We're still working on that. But I was trying to check where we've got to so far, and I think this is the first time that I've used the filtering, the selection of columns. And I think you can see it's made the data frame, when I'm concentrating on the rainfall and these, it's made everything a bit clearer because I didn't need to have the others just now. Of course, when you finish the quality control, particularly for these data, I find that meteorologists, if they're looking at the problems, now remember on your synoptic data, you may have wet bulb and dry bulb and various other things there, which would help you if you found a problem in TN or TX. You can then relate it to those. And so I find that many meteorologists, when they look back at the sheet, and in this case, they look at more of the elements, there's many more temperature elements you've measured that are there. They can be helpful, in which case you would be throwing valuable information away by keeping this selection. But as soon as you're bored with the selection, you just remove it. So if I click here, then I've undone the selection. And what's quite nice is once if I then decided, oh, I didn't mean to undo it, then I don't have to define a new selection because I already defined it. So now I just apply it again, and here we are. So once we have a selection, applying it again a little bit later is very easy to do. And the same thing with a filter. Once you've set up a filter, you don't have to keep defining them. You set them up, and then you can quickly go in and out of using the filter and then getting rid of it. This is just because we're trying to make life easy for you. If you don't find that it's helping, then don't use that facility.
Okay.
Okay.
Any other questions, maybe related to the, or comments related to the quality control itself? No comments? Are these interesting things that you are looking forward to see in your own subset of data and groups? Madam, you wanted to say something? Good? Are we ready to do some work?
So that means that after we've done all the necessary QCs, the data still remains there.
As you work in your groups, can I just, I'm suggesting another task, which and that is that the work in the Gambia, as I think they said, they do have the MCH database, but they have been using Excel for entering data and for supplying the data. And whereas Ghana supplied it from their database. And I have a feeling that the Gambia is now realizing that the difference in the ease with which you can tidy the data is a good advert for keeping your data in a database rather than using Excel. Having said this, I would now like to work with, I think Al-Haji, to now try and tidy the data that he sent so that the Gambia team can use it if they wish. but that is formidable. And so my mild suggestion is that the people from Gambia Met continue to work with their colleagues from Ghana, and it's just Al-Haji and myself and Amsaleh and somebody from Kenya who will try and go through this tidying process, which is quite tricky on R-Instat. And then Al-Haji will share and explain it to the Gambia colleagues. If the Gambia colleagues from the Gambia Met disagree, then they're very welcome to join the tidying group. But I'm feeling that it might be more constructive for them to continue with the work on this data checking and understand that ready for when that applies to their data. Meanwhile, Al-Haji struggles with the tidying of that set of data, which is quite a bit more advanced for the work that needs to be done in R-Instat. So I'm requesting the time from Al-Haji, and that we would work separately while they're doing that, and he could work on his earphones. But as I say, if the and he would then interpret and help and work with maybe even one of the evenings with the his colleagues from Gambia Met. If they disagree and think they're missing out and would like to take part, of course, they're very welcome.
All right, Roger. I think there was one more comment before you go. And could you speak? Also, could you speak in the microphone? You were saying something. That's when after you are done with the.
Roger, can you hear me? Okay.
I can hear you very clearly, Samuel.
All right. So my main concern was we quality control this on R-Instat, but unfortunately, the same problem remains in the database.
Yep.
Yeah. So I'm just wondering how this thing can really transform our database, since I think in 2017 the same thing was done, and then we are repeating it, and it's still there. That controlled version of the database, I mean, it didn't affect it. So I'm really wondering how it's going to be really implemented.
The long and short is, this quality control is not easy, and maybe in the future we would like to enable you to do the quality control within the database, so you can make the corrections directly in the database. But my suggestion now for your database is you will practice with this now, and there's a second half to this where you must decide then how you make the corrections or how you report on this. And then you're absolutely right. I think the next task is to make those corrections. You first have to decide what needs to be done, and then it's important to make whatever corrections in your database, and certainly not just in R-Instat, and maybe not in R-Instat at all. And what you're learning here is that it was pretty quick to take your data from the database and get it tidy in R-Instat. So what you're now seeing is that there's some improvements to be made in your database. And my suggestion is, once those improvements are made, you throw away the R-Instat copy and then just go through those steps again, because the tidying process was so quick and easy. So you're absolutely right that the database is where the corrections need to be made. And even if you were using Climsoft, when we're trying to make the transition from Climsoft to R-Instat and then even back to Climsoft smoother, but we don't want to automate the corrections because we think they need to be done very carefully. And so we've made it very smooth to go from Climsoft to R-Instat, and then we're going to make it quite easy to, if you have got the corrections in R-Instat, to then re-import them into Climsoft, but not automatic. because we want you to think very carefully before changing your database. But happy to talk about that a little bit more. And that's, that will become one of the next steps. And meanwhile, you may be starting to be a bit concerned that I think your data are really excellent quality, certainly compared with many, many other countries. But I hope you're now thinking, gosh, isn't this interesting? We're supplying these data and we've made lots of products. And I can certainly see some very obvious things we must correct. That's quite interesting. And so there's, the whole idea of this workshop is that there's serious reflection done on how you improve your service, and that, as the director was saying, that's going to be a project for a couple of years. And I then think from where you are, improving the quality of the data in your database is going to be quite a quick process. Please remember that we are finding something like 25 mistakes in your data in 110,000 days. From that's, that's a very small problem. So your problems are relatively small, but it'd be nice not even to have those. But don't get too worried, because if you had 5,000 problems out of 100,000, that's 1 in 20. You've got sort of 0.1% of your values have a small problem. Okay, we're going to make it even less than that. But don't worry too much when the percentage of problems is so small.
Okay, Roger, thanks. We are going to go into working soon and reports later after the tea break.
Sounds good. Yep.
All right. Cheers.
Cheers. And I'm going to come back soon with Amsaleh, Antoine, and Al-Haji, if you can set that up, or Al-Haji can set that up. And that can be just doing it this way with him on earphones, or on Skype if it's better to have a separate system. I'll leave you guys to get back in touch with us.
Yeah. Okay. So yeah, I'll just give him the link so you can do with him on here.
Okay, sounds good. And that's because it's a climatic data set, and so there's key fields. So it's Kumasi, the 16th of how easy to write a report of the values that you've gained. So I didn't write this. This is just because I was on that day when I made the change. And so R-Instat has added that automatically to the rainfall column and in Kumasi on that day. And so that's really rather helpful to the data people. And now I can export this to Excel or save it in any way I like. So that's the other daily data editing and entry. Let me go the long way so you remind yourself where it is. It's in tidy and examine, daily data editing and entry.
Okay.
So it's in the tidying of the data, because you're now going back to doing more tidying and examining. And so I think that's the right place for it. And here it is.
And could we change the period today?
What, the period?
Yeah.
Which period do you want?
Same thing.
Okay, so that's just for one day.
Yeah, okay.
I haven't checked this very much. I hope this is going to work. I've usually used the month. And so let me enter the data. And here we have one day. And the rainfall was missing, and these were there. So now I could just do something with one day. And if I want, I could add another comment. This value was missing. Okay. And and these I can view, so I can check if things are sensible. I will make a change here. I'll make that missing again and return. So I've entered and I've got a comment. And now it's another comment. It happened to be on the same day. So that's where you have a single day. I prefer to use the month at least so that I see the value that's wrong in context. So I know that's wrong, but I usually, especially for temperatures, I want to see the few days before and the few days afterwards. So I've tended not to use that day thing because it doesn't show me enough of the context for that element, which is quite useful.
So it seems that doesn't seem to work on their laptops.
Which one? The different.
Yeah, when you are adding the comments.
Oh.
For either, I'll just check it out.
It may not. This facility hasn't been used so much.
Okay.
So we're looking for people to use these, and if there are little glitches, then that would be very useful for us to find out.
It works. Works for the month. I went to go days. Looks like you right.
By the way, the other reason added that facility in general is that sometimes we found that people have provided data and then we need a little bit more data. And so you can change the end date of your data and add a month or two in R-Instat itself. And then you can send that through. So later it gets into the database, but we didn't have time to wait for GMET, let's say, to put it in the database. But for our picture work, we wanted the last year. We still think the data entry, proper data should be done into the full database. But just occasionally there's a month or two to infill or to add at the end. This is an extra facility to do that. But yeah, please test it. And then if there's something wrong, then please tell us. Are you still there, guys?
Yes.
To feed you left.
I think we can consider what we
try these things because, as I say, these are relatively recently added, and we'd be delighted if people find them useful and start testing them, and we'll be very quick to correct them. We're trying to get updates each month, so you shouldn't have to wait long if you find problems for them to be resolved. We'll try and describe workarounds where we have them, but when we've got more serious problems, we'll try and solve them within a month. And then leave the synoptic and the hourly data, the automatic weather stations, maybe for another occasion, because I think there's been quite a lot that you've covered already just with these elements. I did want to just check one thing with you on those data. Let me come back to this. So I noticed on the data, although it was missing, let me try and do this for the month, 1st of February, 1982. Undo that and enter some data. Okay. So here, I wondered what these other variables, is this ground temperature? I don't know. I wondered what TG was. So this is what I was thinking, that the grass minimum temperature, I noticed, is if we were trying to correct temperature data and we found problems, wonder if the graph, you know, we've got other elements that are fairly similar. And, you know, where there are problems, we could look at the difference between Tn and Tg and maybe use Tg to make some corrections, because, you know, that could be useful if we found problems. I notice it's always slightly less than Tn, and possibly very highly correlated with Tn. So I thought that's what I've seen, you know, you met people doing, of in these synoptic stations, you meteorologists have very many temperature data that they could use to edit and worry about a variable like minimum and maximum if there's a problem. And so it does seem to me that the grass minimum could be a very useful thing, highly correlated with Tn, I would guess, to be able to use in situations where you wanted to check a value for Tn. You would expect it to be slightly greater than Tg, and if it's totally different, then there's something going on, then you might put it to missing, or you might use Tg to say, well, it's usually 0.8 of a degree higher or 0.5 of a degree, and so you could use that to get quite a good estimated value of Tn. I don't know. I'm not. This isn't my field. I just deal with numbers, but there's just a thought there.
Yeah.
Okay, I'm going to carry on now to the station data, the one different sort of data. Is that all right? Data sets we used, people said, oh, we've got better data sets. And I hope you have here, because the data set I'm going to use still has 10 regions, whereas I've now checked with Wikipedia, of course, that you have your 16. And so maybe you've got a better data for maps than we've got here. But I wanted to show you what we've got so far, just generally, and then also a new facility we've just got working now that maybe can be another check on your station coordinates. So let me show you those two things. First, simple map, April, with a list of the stations. And I'm using that because you've given me the district for each station and the region for each station in the file. So this file has the type of station, the district, I think the type of station is a factor, and it's 808 stations. So quite a lot of stations. And I want to do a simple map where I first show you Ghana, and then I show you your stations on a map of Ghana. Let's start. So I've got your stations. I haven't got some to draw a map. This is in the climatic directory, and I can import and tidy shape files. So I'm going to use a publicly available shapefile, which I've downloaded. So GADM is a public site which has shapefiles from each country. And a GADM 0 is just the map of Ghana. And I'm going to import that. And I'm going to keep this open because I want to, so it's very bad the way this is laid out, and we need to improve it. You've seen that the cells get very long now, but never mind. It's the data set is there, and it's the geometry which we're not presenting very well. So this has the name, which is Ghana, the geometry, which is important, it's a shapefile, and the longitude and latitude. I can go back here and get GADM 1. GADM 1 shows your regions. And I'll keep that open. And then I want to have GADM 2, which shows the districts in the regions. Okay. So here we are, that here I am in GADM 2, and you see this is a bit smaller, and GADM 2, I don't know how big it is. It has 137 districts, whereas GADM 1 has 10 regions. So this is still your old regions. You may have a better shapefile, which we could use for demonstrations in the future. And I think that looks quite nice. Now, the input use your metadata. And I've got the longitude and the latitude, and I'll put some labels in. Your station name. Probably can't have many of the labels because you've got too many stations, but let's have a look what that does.